Good morning, everyone. Sorry, I was already have this window open here, working on some maintenance tasks already. Thanks for joining Modern Apps Live this morning. I see we have an esteemed guest list this morning. We have several people I haven't spoken to. Well, Robbie, welcome, and Nate Reed. Who haven't spoken in a while, and I said, oh wow, we've got a bunch of people joining. Welcome, everyone. Okay, cool. A few things I was going to talk about today, but first and foremost, to make sure that everybody is aware that we like to keep this very conversational, very casual. So if you have any questions at all about anything or anything particular you feel would be good to bring up and to chat with the group about, feel free, whether it's now and any point. If I start talking about something, don't hesitate to speak up, chime in, interrupt, change the direction, ask a question anytime. Like to keep this very casual call. So yeah, today I wanted to continue that conversation, the ongoing conversation we've been working on. I'm going on paternity leave in the mid-March probably. And so a key goal that we have between now and then is to take the platform itself and to really start cleaning up things and making it making it really nicely manageable. So that way, as my peers and other team members take over the administration duties, that it's reasonable to do. Because I think as things typically go, the whole platform that we run on here is been bootstrapped together predominantly by me. And so while everything has, there's a flow chart for everything, it's mostly in my mind, right? There's a lot of documentation that doesn't exist, and there's a lot of things that were, very, very quickly done to get something up and running, but that weren't built properly, or with all the features that they need. Not that that's necessarily a bad thing. It's always been the intent to come in and build more and more features and capabilities and get these things really nicely polished. And so now is a time we've been working on that. And so one of the big things we're talking about is more urgent, is having better visibility into issues that may occur across the collection of repositories. So we've got really, you can see here in the Modern Apps Ninja repository, there's 64 repositories. A lot of those are, these are not all, we have several repositories in here that we could call maybe experimental. They're not like the main part of the program when you go and look at courses and guides on the site. But we have quite a few repositories in here that are of common types that we want to manage, we want to fully lifecycle manage. And we also have Modern Apps Ninjas, which is currently the org where whenever anyone joins the domain, that they have a member page created, and we've got 700 repositories here. And we've got to make sure that we can manage all of these. And one of the common elements, right, is inside of any repository, they all have issue tickets. So issue tickets could get placed on any of them, and then what, right? So like that's one of the things I was just looking at here when we started the top of the hour was one of the most regular maintenance tasks is just going through this list and keeping an eye on open issues and pull requests for common problems. There's some ways that make it a little bit manageable now. Like one of the things is, of course, you can watch any repositories, and so you can see like this is watch option, and you can decide what you want to watch. And then for the things you're watching, you've got your notifications panel, and you can go through and see. But this was kind of the notifications again, a temporary way. I was planning on having alerting and eventing, essentially, that I guess alerting is the right term, alerting for when things happen that might need attention. But when you have 700, 800 sites, Plus, it's it's just kind of futile to think you can't just look. You can't use the notification system in a meaningful way. It's too many notifications coming in. So we need to have some sort of centralized information and dashboarding services. Excuse me. To do that. Yeah. So like right now, the other thing that's kind of nice is that when you go to your org in GitHub, the default view that shows up sorts by most recently modified. And so that's kind of nice thing is that, because one thing I know is assuming I've checked, I go through and I check all the repositories and I know the state of things. The main thing I need to be concerned about are things that have changed, right? If nobody, if anybody does a pull request or opens an issue ticket or anything that might need administrator interaction here, then that will cause it to bubble up to the top of the list. So that's helpful as I go through these. I can see that if something had moved up to the top of the list, that means something's changed, and if it moves down to the bottom of the list, it probably means I can comfortably not look too closely at the outstanding issues. But none of that works still, because there's also always issues that we can't close right away and need to come back and revisit. So yeah, we need to have a much more robust system for central viewing and alerting around issues. So what to do? And so I've been, and that's the thing is I've been doing a lot of research on that this week, and I think I have a plan in place. I'm going to review some of the technologies and thoughts, and definitely be very open to input on this as well if people have suggestions. And so like the first thing is if you don't need to, don't build something, right? And we've got a lot of things that we may potentially need to build. So I'm a big fan of looking and seeing what is out there, seeing if it meets the needs that we have in the community, and if we can, consume a product rather than develop it. And I haven't found anything that I think meets the bill that's a ready to go, open source type of solution or service. One of the main criteria when I'm thinking about anything that is an important component of the tool set that we use to manage this, I have no problem if something happens to be a commercial software necessarily, or a software as a service. Those are great things to incorporate in the stack to accelerate, getting to your goals. However, some of the unique constraints in this community is I want to preserve the ability as much as humanly possible for any members of the community, anybody, to be able to help with administration, right? That's, we have mostly VMware employees in the community today, but we have quite a few folks who are not VMware employees. And, I think it's hopefully fairly obvious, like what the value would be. A lot of what if there was a non-VMware employee that wanted to come and do a bunch of work here potentially and help make, our administration job easier? That'd be great. Absolutely. That'd be, wonderful. So, and then you can imagine that this also could get political. So if we have this program and I give people access to be able to, get access to something, and that something has a cost associated with it, that's not non-starter. We do host assets. We host a few online Kubernetes repositories right now, and with the intent to potentially host more as needed. But we've got to keep that reasonable about how we do it. Like if I host a Kubernetes workload, I can put a service on it that handles, I'm just paying, the hosting fee. Now, if I consume some SaaS, then I'm usually dealing with per user licensing. And so there are several things that can potentially help centralize GitHub issue tickets. GitLab, right, has a multi-repository issue ticket centralization feature called group issue boards. However, that is exclusively part of their enterprise edition product. Likewise, there's several other good candidates. You can use things like Jira. One of the big ones for GitHub projects is ZenHub. ZenHub's a great service, and they do have a nice free tier for their service. But again, it's like, if we got into actually using this the way that we'll need to, we need to have, the ability to use this as much as we need to. And I think it's just starting to look at any of those services. It gets it to the point where we'd have to be at a paying tier, likely have to be at a paying tier to be able to do things, or be facing unpleasant restrictions. And to get that, it's usually cost for, if you want 1 to 3 users, and you're paying, in the next thing you're paying per each user that's accessing the service. And that just doesn't work for an environment where we really want everybody to be able to participate in the administration. And so thinking about defining what is the application that we need, so there's a couple things that we want to have, right? One is central views of all the issue tickets across all of the repository, all the managed repositories, and also central view of pull requests. And mostly these are things that users manual requests for attention. We want to make sure we can see those and handle them. And then likewise, there's the health of the projects, and there's a few layers of things that we may need to put in for overall health observation. But I'm going to kind of separate those two things. So first, we're going to look at centralizing user request visibility, and then one indication that we can. So health is an interesting thing, right? Because all the sites are static sites. All the sites, every time you go to any site that's modernapps.ninja something, right? It is a statically hosted site. It is a file bundle of HTML, JavaScript, and CSS that's basically parked on a file server that uses the HTTP protocol to transfer. Yeah, right. So all those sites, you go to ModernApps.ninja, there's a bundle of CSS and HTML that gets served to your client. Your client takes it and interprets it. It doesn't do any server side rendering. It is just static serving. And so there isn't how you would do the site availability, and there's a standard up down stuff. So we'll get, or I'm looking at maybe using Tanzu service mesh or something for that, but we'll put something later in place that will go through and do some synthetic transactions, and we should ideally eventually get to test the full synthetic transaction testing. That'll take a while. In the meantime, the one way of monitoring service health is by the actions. And so when we monitor issues, it's very straightforward, right? We can very easily make a REST API call to GitHub to gather the issue tickets. And very simple thing. Hey, for this repo, give me the issues, and it'll give you all the issues in a nice JSON format. Same thing for pull requests. And likewise, we can do that for actions as well. And so with actions, one thing we can do here is anytime we see an error message in the action. Now, and to do that properly, I need to actually finish cleaning these up, because I have some things out there like this where this org number change says that there's an error, but it's not really an error. And I know this because I left it that way, and I left something in there that was causing the error to trigger that I didn't remove. And it's just one of the things I still need to clean up. So we'll get. And so I'm thinking we need something that shows a sortable, filterable grid, data grid of issues and pull requests and potentially actions. And then as we have those things, right, then we want to think, okay, well, we need, the list is nice, having a page where I can go see all of them in a central location and do the sort and filtering. That's nice. What about alerting, right? I want to be able to run jobs against the data there, and be able to create rules that will say, hey, for everything that's been open for too much time without having been triaged, then send an alert, another red flag, and then some dashboard functionality to where I can take the list of things and have the top 3 issues based on some criteria that show on a selection of tiles. Just a couple pages, but the core of what I have in mind is that is essentially a data grid. And so thinking about how would we create, starting off with let's just say I want a page. I want to build a page that has a data grid of all the issues across all the repositories on Modern Apps Ninja. And so this gets into a lot of interesting questions about application design. And so first and foremost is the data sources, right? We have to think about the data source. What data do I want? I want to have all the issues across all of the repositories in the Modern Apps Ninja org. Or wait, do I? Right? This is one of the important things that we haven't done in the org, but it's been needed to be done, is not all the repositories in this organization are equal. We have we may have multiple different sets of policies and standards that we might want to apply to different cross sections of repositories in an organization for arbitrary reasons. Right? We can always say, I'm going to create an org that try to make it very purpose built, so only the things that come in but are in that org are all the same type. That wouldn't be a very good model for the way that I think Git, the levels of organization that Git has available. It's really kind of this 2-tier hierarchy of org and then repositories within the org, and that's all that you have to kind of keep things related. And so within the different repositories, it's important to be able to use metadata tagging to use tags to identify what class or type that something may be. And so there's a number of different types that might exist, right? From categorizations like things that are really actively part of the Modern Apps Ninja website domain, and things, some of these things here that are not, they're just using this for a bucket. Like I think VMware VRO, this one here is not specifically associated with any of the other activities per se. This needed a nice friendly place to host that, and we're a nice friendly place to host things. And admin private, we use this for the program. However, it's not a course, and it's not a guide, and it's not the homepage template. And so we need to have a better way of using tags consistently. And we do some of that, right? Like right now, when we create a course or a guide, we create them from templates, and those templates do have a set of default labels associated. So we're just going to continue to run with that. And so one thing we need to make sure is that in order for me to get the data I really need from here, I need to not just be able to run through all the repositories here. I need to be able to go through and find the relevant repositories. And so we need to make sure that we tag those. In this case, the categorization I'm thinking of isn't even necessarily courses versus guides, etc. I don't really care. I'm really thinking about the users, and any one of these may involve a user. I'm really thinking about this concept of managed versus unmanaged repositories. And so let's say if I'm the admin of the Modern Apps Ninja org, and I say, or we are, or whoever is, right? But we say, from a policy perspective, we have things that are kind of a regular life cycle managed part of the program, a standard type. The homepage, the template, the new guide, new courses, etc. Each of those are kind of just specific types. And then we also have things that are more random, an experimental project. And so it's kind of the biggest bucket is not very granular standards, but just kind of the big thing is something's a managed object or not. And if something's a managed repository, then those are ones we want to look at the issue tickets. For one like this, I have a team, a team wanted to run that repository. It's not something that, say, the community has responsibility for as a whole. It's more the individual administrator. So this is, I guess, that concept of community-based administration, things we want to manage as a community. So yeah, so we need to label these so I know which ones are community managed, and so that way those are the ones we want to have in issue tickets. Or, maybe even a better way of doing that rather than trying to infer purpose is to make it more arbitrary, like an opt-in. Any repository that wants to be viewed in the centralized issue ticket dashboard could have a leg, some sort of opt-in, opt-in label. So we can create some arbitrary label that if it exists on one of these repositories, it will get opted in, and then we'll just make it the standard thing for all the templates that are used when we do automated creation. There's one thing that is common to the one-off ones here that would be unmanaged. They would not be most likely created as part of the automation. They'd be one-off creation. So anywho, all these lovely things we got to think about. So okay, so that's one thing, and I should note this down somewhere, but have it in my head for now. We've got to have a good common set of labels so we can identify which one of these repositories that we want to target for various activities. But are labels good enough? There's another tier beyond labels that we may need to consider. We also are indexes. As what we want to do is when we gather all this data, we want to be able to gather it quickly. We don't want every time that we want to view we want to view this dashboard that it's going to have to go through and crawl every single one of these constantly. There will be a certain amount of crawling as applications do, but we want to have a cohesive set of data. And then we also have to think about how are we going to query the data, right? That's a big thing. Like one of the things I was actually wanted to look into now is, what is the GitHub API going to give me, right? And in terms of how close is it going to, like, is it going to give me all issue tickets per org? Or am I going to have to create a job that says, first I'll do an API call that asks for all repositories within this org, and it will send me the GitHub API would send me back a JSON formatted list of all the repositories in the org with the key metadata, including tags. So then I have to have take a loop and say, okay, request all the list of orgs. Now that you've received the list of orgs, iterate over the list of orgs to determine which have the label that says that they want to be part of this whole thing. And then after you've done that permutation where you've checked to see the list of, now I've got a filtered list of the orgs to only, the orgs that I want to include. And then I have to find the issue tickets, and assuming the issue tickets or request has to be done at the repo level, then I have to have a loop and iterate through each of those repositories to go and individually pull a list of issue tickets. And then we'd have to concatenate the list of issue tickets from each of the different repository level pulls into one common data set, right? And so it's like, when do we want, and that's one of the reasons why indexes come into play, right? Because when we think about what data set do we need, well, I want to have something that centrally lists all issue tickets across all my sites. Well, one thing I can do is I can, if we need to have a process like that where I say, okay, well, we need to run this job where I need to loop through all these repositories and gather all this data, that doesn't have to be done constantly. We want to have something that's near real time, maybe, or we can decide, do we want this to be updated based on an event trigger, or do we want it to be updated based on when the client loads the data, so the client's waiting? Do we want it to be updated multiple times a day or on cron job basis? Because what I'm thinking we'll probably do is have an index, create an index to where you probably use GitHub Actions to go through and do that crawling. Come through, crawl here, identify which of the repositories we want to target, and then which of the issue tickets we want to pull from each of those repositories, and then pull all that data into a common index, and do that using GitHub Actions in sort of an out of band, meaning it should be updated. I'm thinking event driven or periodically. Event driven is definitely the way to go. The question is it start to become, when you've got all these different websites that could potentially generate events, you have to be very, very careful about when, how you choose to trigger things, if you want it to always trigger very consistently. There's lots of, so that the good and the bad there is we probably would definitely want that sort of thing to become event driven, doing it event driven from the onset. What that means is right, anytime we have to have events associated with every single repository to watch for that. Or we can, have the org level event filters, but event watching, but then we'd have to be able to like filter for very specific things happening if we're going to watch events at the org level to do event. So I think the easier way to do it is probably start off with like a cron job based index. So where we have maybe a few times a day, have a crawler go through these repositories and sync all the issue tickets and pull requests into that central central index. And the index will just be JSON data that's sitting on a repository. I think I will create a repository specifically for hosting that data. Or I'm also thinking like, maybe it makes sense to keep some of the data near the source. I don't know that I want to have a religious opinion that all data would be centralized for indexes, but if there's not a better natural place for it, then I'll create a repository to centralize the data, and we'll host, the indexes will be a JSON file or a collection of documents that are JSON formatted in a particular repository that we can use the GitHub API. Now, another really interesting factor is GraphQL. Right? GraphQL is like game changing from an API perspective, right? Because and it addresses that specific challenge that I'm just talking about, right? In order for us to display the data we need, we've got to collect the data that we need, and that involves either running a bunch of jobs or at the time of request, or running a bunch of jobs at different times. That way, the data that you want is already prepared. Now, GitHub. And I should probably, I don't know, I'm sharing this boring part of my screen, but GitHub has really robust GraphQL support. So I wonder if we can, let's see, let's just look at like GraphQL, maybe like look at Apollo client or something. Let's see if we can see a good like interactive GraphQL. But GraphQL is a way to request request API stuff with a SQL-like language. And so when we just think about that example I just gave, I want to get some very, I don't want just any data, right? Because the REST APIs are very generally, oh, you want some data, here's the data, and it's up to like the developer and the creator of the API to determine how much functional stuff that they want to put in that API to let you limit the scope of the data that you request. But generally, it's not a very sharp tool set. It's not like you're going to go in with a REST API generally and scalpel carve out this specific subset of the data that you need. It's generally, I want some category of stuff, and it's going to dump you back the bucket of the stuff you asked for fairly unintelligently. And GraphQL provides a really great way of going in and it's very robust to be able to combine different sets of data, and you can just do a lot of really intelligent querying in how you query data through a GraphQL API, and that can completely remove the need to do a lot of these indexes. And I haven't experimented enough with GitHub's GraphQL API yet, but it could be such that if we use the REST API, we end up needing to do all this extra work to create indexes. Whereas if we use the GraphQL API, maybe we don't, right? Because there's kind of that two things about indexes. Like a lot of times you're using indexes exclusively for performance, but other times you're using it really, it is always that performance element, but it's really more about aggregating the data. It doesn't have to be, it's not like a search engine response where it has to be incredibly fast. But it does have to be fast enough for user request. And GraphQL meets that, right? GraphQL is fast. And it gives you that way to, like I said, surgically request the data. So one of the things I still want on my list is playing a little bit more with GitHub's GraphQL interface to see if I can do a GraphQL request to gather all that data very surgically from that we need, then we can just eliminate all the indexing conversation, right? Then it's no longer, I need to come up with a complex multi-step workflow with a stepwise algorithm to be able to result in the data that I need. Then it's just a really nice, well-written GraphQL expression, and I get all the data that I need. So I have that as an action item, right? To play more with GitHub's GraphQL API. There's a ton of really cool stuff happening right now around GraphQL. So if that's something if you're following APIs, GraphQL is a place to go. And that's the big thing, is it really can simplify your application logic, and people are trying to get to more and more portability and flexibility, and trying to move towards more webified models and data structures. And it's like, well, the GraphQL API, you can really meaningfully have data sources that are purely API driven, that really give you a robust without needing to implement additional tier of database stuff, just straight API to application logic. And if you just compare it to how what you have to do to get the data you want through a traditional REST, I think there's just a tremendous amount of efficiency and simplification of code and everything that can happen with that. So now some other key considerations, right? So what application we want to build? So we want to build the client-side application when possible. So we're not opposed to doing some server-side stuff and hosting some things, but in general, like right now, every single aspect of Modern Apps, it's all client-side. There is no server-side components. These are completely static sites, right? And so again, every different one of these repositories in here it presents a site, including the member repositories. Each of the member repositories has a bundle of HTML, JavaScript, and CSS files that GitHub pages will serve as a bundle, and your browser will download that bundle over HTTP and display it, as same as if it were server side rendered, but from a traditional web server. And so we've got all of these bundles of files. Sorry. And that's what makes up, and this is really like a collection of sites, because I can go to courses, and maybe I click here on as soon as I click out of the homepage repository and into the course, my domain looks the same, right? I'm still ModernApps.ninja, but I've moved a completely different bundle of HTML, JavaScript, and CSS, right? A different subsite within this overall kind of distributed collection of sites. And so let's see. So this is all client side stuff that's happening, HTML, CSS, and JavaScript. It doesn't need a server, and I can have some interaction. I could actually have a lot more interaction in here. You can load data models locally and have all of the animations and CSS. And if you could think of the fanciest website you've ever seen, flashy and Hollywood, whatever else, you can do that all statically. I mean, there isn't any much in terms of fancy appearance that needs a server-side component. And so, okay, so if we want to do this in a client-side component that ideally will run in JavaScript the client side, and that prevents us from needing to have a server. And so, so how can we do that? So what I want to happen, right, is I want to go to a page. It doesn't matter what page, that we have. This will create some page somewhere in this Modern Apps domain. It could be just a random page. And I want this page to have a table on it with HTML data, or a table that gets filled up with, populated with HTML data. Pretty straightforward, right? I mean, that's kind of one of the things that's happening here. This is an HTML element that has some counters, and I think I'm feeding these numbers statically. These are old numbers, but I can also come in and use some type of JavaScript to say, replace these numbers automatically based on some calculation. So then I have something like that, but it's going to be more of a database spreadsheet table, and use now this element here, right, and stuff that runs in Hugo. Those are things that get built at build time. And then of course there's things that we want to modify at runtime, and that's one of the big things that's happening in the kind of cutting edge of the web now. Is we've had frameworks like React and Angular that have become the most popular ways to give a good user experience for clients. At the same time, server-side frameworks are really good for handling enterprise features and really complex, really complex systems and stuff where you have a lot of private data you want to keep. But the older way of doing things, or the traditional way of doing things, has been about making every page dynamically crafted. To where if you were to look at a page like this from an older system, it's like everything is essentially from a database. You'd have all this text that came from a database, and the server side might dynamically render it into HTML, or depending on the web frameworks that you're using, you might have the client side dynamically render this as HTML. Generally, Angular and React are really built to bring that kind of object-oriented, class-based programming capabilities into the client side. And so that way, generally what happens if you're using a React based solution, you have a React router that says, for if you come to mysite.com/something, what site is it going to serve you? It's going to serve you generally a dynamic built web page that'll grab a template and then look at some data source and populate the contents on that template from the data source. And now with a lot of the new stuff, there's a lot more of this content is being served statically and even edited statically. So Jamstack, the idea being is if there's something that's meant for human editable content, why not save it as text, as a markdown, something as a file, rather than dynamically building every page in its entirety. So we're kind of in the middle of that. And where you want to be with that is where the trends are going right now is you want to serve as much static content as you can statically, and use build time rendering for some things, and then only use the dynamic runtime rendering for the things that you need to. As I think, so the industry went like way too far in this direction with React and Angular, to where we're in single page applications, to where we're doing way too much runtime rendering and not nearly enough build time rendering. And so we have new frameworks now like Svelte, which is really like, you'll start to see Svelte, like if any place where you see people list things like, oh, you can do this with React or Angular or Vue, Svelte is quickly becoming the new kid on the block in that category, as this allows us to do a lot of things I was talking about, right? What we want is we want to be able to have as much as we can pre-statically rendered, and then only to have a real-time rendering when we need it for a real-time rendered component. And I'll talk. Let me give a little more example of what I mean there, right? So notice this here, it says Svelte compiles your code to tiny frameworkless vanilla JavaScript. Your app starts fast and stays fast. So it's like, so meaning like with other things like with React, it just uses a lot of JavaScript all the time to do everything, because it doesn't do anything at a build step. So that's like, Svelte is a radical new approach to building user interfaces, whereas React and Vue do the bulk of the work in the browser. Svelte shifts that work into a compile step that happens when you build your app. Right. So let's talk about what that means practically for us. Right. So what I want to do is I want to build something that looks like a data grid that's sortable and filterable in a web page, and then I want to populate that with data. And so that's two things. It's the data I'm going to populate it with, and it's some sort of JavaScript application that I want to use to display my data grid. And so when I build that, I'm just going to look for like a JavaScript data grid, right? There's going to be tons of open source ones. There's going to be ones that are paid, right? But if I want a JavaScript data grid, and I can find JavaScript datagrid.com. AGGrid has a nice one. We can look at Clarity Angular. But let's just look at JavaScript datagrid.com. Right, this is one I think that's a paid one. But the point being is like if you can go through all of those links and you're finding all of them, is there something that looks like this that they already made? right? They already made, and this one's not open source, but there's tons of them that are purely open source. And all you need to do is take their JavaScript, and they've already got it. And they got the sorting, and they got the filtering, and they got instructions on if you want this table to load with the data and have it load a certain way in advance. You follow their instructions, and bada bing, bada boom. So here we have one JavaScript that we want to have load at some point with our page. That's one. Now, we also want to use JavaScript to populate this table with data. And so, and that is the perfect example to kind of illustrate, what's happening in like what should be static versus what should be dynamic if you really want to get optimal around user experience, right? Like this, I want to load this application that has this data grid, right? That I can do at build time. That's most of it. Like, what do you think has more space? The data that you fill this table with, or all this stuff? Now, if you have a really, really, really massive data set, yeah, you'll have more data than. But on most data sets that you have, unless you're doing new stuff, machine learning, and really big data analysis, most data sets you have, they're going to be much smaller than the actual code needed to make all of these data grid features work. So I can take all the data grid features. I don't want to have real time, like even if I do like CICD, I don't want to have pure real time incorporation of updates into a live application in the event that this data grid app here gets an update. For me, I may want to frequently stay up to date. If I use this data grid, I may want to frequently refresh my code with the data, but it doesn't need to be constant. And so a great thing would be take the data grid itself, use this as a build time render. That way the JavaScript needed for this is already, the combination of JavaScript, HTML, and CSS that needs to make this happen is already pre-rendered. And then we can say on the client side, at runtime, the client we could have the client make the API call to GitHub at runtime and pull the data down. And so we'd have that combination, right? Stuff that we could, most of the stuff that we would render at build time for that, to keep everything real nice and slim and performant. And then all that becomes statically served. It's just a file that I download. And that's probably the most important part, right? Is all of that dynamic database stuff that dynamically builds website. That's all major security holes. And if I take all this stuff and I statically pre-build it and I put it into a bundle, and my interaction with my web server is just downloading a pre-built bundle of HTML, the security vortex of that model versus the traditional web server model, I mean, it's not even close. This is all public data that you've just downloaded the file, and the only interaction that you're actually doing is locally within your own browser, or potentially to some, decoupled web service. And so, yeah, I think this model is really, really efficient. It's really secure. And it's new. So it does requiring, when you're creating your applications, you have to be thinking about it. It says you can, in all this ability to do this partial static rendering is usually called selective or partial hydration, right? It is something that several frameworks now support. It's becoming quite popular, but it is not something that like, oh, we can just take your old app and it will just work in this sense. There's definitely things that some automations that can kind of do that. But if you have a traditional app and you want to get them to be optimally partially hydrated, selectively generated applications, it is something that usually will require code level modification to get it right. What we can do in these frameworks like Svelte, or say, when do we want JavaScript to load if there is JavaScript? So this does a couple things. One is that it significantly reduces the amount of JavaScript that you'll ultimately end up needing by pre-interpreting anything that it can as just HTML and CSS, because that's what ultimately what happens with a lot of your JavaScript is it does some manipulation of HTML and CSS that creates some HTML and CSS in a programmatic way. And so this can do that at build time. And so your package just becomes an HTML, CSS, and and then the only JS that you really need to load to the client side on that is stuff that deals with real-time interactivity. And most of these things like animations and transitions and beautification features, they've been built into the browser primitives now. And so there isn't as much of a need to try to do that with fancy JavaScript. You can do these can do a lot of stuff with just HTML and CSS. So it'll pull out a lot of your JavaScript during the build time and leave in what you have. And so, yeah, so Svelte is one way of doing this. There's a lot of other interesting different things. I'm kind of leaning towards Svelte, but and Svelte is a way that you kind of you would, since it's very much like packaging like a React or an Angular, where you can build an entire multi-page website all with this, but it is more often used to build components. And this is actually a really good framework to move towards increasingly component-oriented design. And that's one of the big things that's happening now in the web is moving towards web. It was really a big movement towards components. As much as there's been a movement towards Angular and React and Vue over the past few years, those were kind of, each one is its own non-standard kind of community. I guess they're standards in a sense, but they're not like web-wide standards. And so there's a React way of creating components, and then there's a Vue way of creating components, a Svelte way of creating components, etc. Well, that's all starting to change, and that's actually part of the reason why Svelte is gaining in popularity, is because React started to do the way componentry the way that it did components because of a lack of, there wasn't a standard, a truly wide standard way of doing. Now we can see how popular React and Angular Vue has become. That should be something that's just part of the core web capabilities. And so now we have web components just within the past few couple, just really with the past 2 or 3 years, to the point where really now it's becoming really big, really viable to be able to build a web component based solution using pure standard components. So now React components, so Svelte actually just builds standard web components, where React and Angular and Vue do a little bit different. They ultimately have to run in a browser, right? But they do a lot of magic to make that happen. But now you have like an update in the web standards themselves with web components, to where like a good way to like see some of the things that are happening here is if we look at like VMware's Clarity system. Historically, this was built around Angular components, because since Angular had this whole class system and modules, and you can create classes and modules and really do this kind of object orientation style of management with Angular. Now that's being built into this pure standards based web components. And so now you can see these core components are web components. And we can go in and like, how do you use these? Let's see if where's my example? Oh, here we are, code. So now we can just access individual components in these with just simple import statements into regular vanilla JavaScript. And the performance is a lot better than when it's in vanilla JavaScript, and it's a standard, and so people don't have to develop in different tools and get as many different imports and components to get them to work when they move towards pure web components. So I know that's been a bit of a messy conversation. We're getting to the top of the hour. I kind of wanted it to be that way because this is the realities of like, I'm thinking of developing a front-end application. These are all things, that we have to consider. How are we going to do it? We want to get our data grid. We can, do we want to do this based on a server side rendering, or are we going to do it client side? Right? If we're going to do client side architecture, how are we going to get our data? Getting our data, we're still figuring out, right? We have to get data. I have to check the regular REST API from GitHub to see how close a standard REST call can get. But I don't believe that a standard REST call is going to get us close to what we want, right? We want for each of the repositories in this organization that's managed, not all of them, but let's say it falls under that, community managed label, if you will. we want to be able to gather all of the issue tickets and all of the pull requests from each of those repositories specifically. And so, yeah, we talked about that. And we could get those either through REST API calls, potentially. I don't think that's likely. Most likely we'll run, if we were to go the REST route, we would run some batch jobs to create some indexes that will allow us to get simpler calls of the specific data we want. So we'll have pre-compile the data, that when we want the data, we can get the data set that we want. Or the better alternative, if we can wing it, would be to use GraphQL, right? Which should allow us to just come in and make an actual API request to just directly get the data that we need, so we can get the data we need right off of the bat and don't need to jump through hoops to kind of condition the data, right? And then, then so how are we going to do it, right? We're going to use a front-end framework of some kind. And so right now our web pages are served with Hugo, and that won't necessarily change. Yeah, I know I mentioned Svelte, right? But what typically how this is done, right, is, where was that one page with a data grid or here? Like, here's an example of a page with a data grid on it. So just like this, I don't know whose web page this is, but if this were one of our pages and it were rendered with Hugo, right, there's no reason why you can't say, okay, I can have a Hugo template with my regular Hugo page, just text, and for the data grid component itself, it's going to insert a component, and that's the way that these things are typically done, right? Is when you have a component like this, it's generally brought in as a single as a web app, as a single page app, as a component that's dropped onto a page that has other text into around it and so on. And so, yeah, this can be served by Hugo just fine, right? Because Hugo is going to, this is JavaScript, and so Hugo will bundle all your stuff in HTML, CSS, and JavaScript, whatever JavaScript you want to pass to the client. It's just a bundle. Hugo just creates the bundle of files, posts it on an S3 bucket if you want to. S3 can do static site hosting. We do it from GitHub pages, right? And it hosts that, and then the client downloads it, and then the interaction, the hydration happens at the client side. And so there's so many more factors to consider. Like one to consider is a big one that comes up, and I know we got to drop, but just the last thing I'll mention here is, can we get this data without authentication? This is one of the important things to remember, is when you're doing development for client side stuff, you really have and runtime stuff, like anything that we do at build time, I can insert secrets into the stuff that happens at build on my server side. My server is doing the building. And so I can use all my GitHub secrets. I can put secrets in anything. I can gather data, make API requests. I can do any of that I want at build time using my secrets. But at runtime on the client side, unless I'm going to send my secrets down to the client side, then I can't use secrets and code that I send down to the client side. Right? I have to, if anything, maybe public keys, stuff like that potentially, but I cannot. And so what does that mean for the client side? That means, fortunately for us, I can make requests of the GitHub API without authentication. And I think that will do the trick. But what happens if I need to make an API request that would require a level of authentication? That requires a whole nother level of complexity that I need to be able to, do a client login on this side. So that way I can either generate a hash or a key on behalf of that client, or have to do like a login with GitHub thing where I can have them download the keys that they need through a login process to be able to, have the individual who's using the app be able to make the data render. And then there's even further you can go with it, is you can have partially preloaded data, right? You can have some data loaded at build time and then have a sync update process that happens at runtime. So that's where I'm at so far in the development of this app. I think the next steps are I think the framework, right? Am I going to build it in Svelte? No, I think I'm going to stick with Svelte right now. I'm really looking at some things outside of Hugo. I think for now, Svelte plus Hugo. This may change. Svelte plus Hugo is a good combination. of getting this particular web app that we want to build that has the data, ready to go on it. So look at a process, using Svelte and Hugo to generate a page that has that, and then we have to write a little JavaScript function to make an API call to GitHub and play around with that. If we want to, I'll look at the GraphQL. I really need to get more into GraphQL. I spend a lot more time with REST than GraphQL, but I think, I want to spend a lot more time with GraphQL because it's going to be, I think, as big of a standard as REST has been. I wouldn't say necessarily bigger. It'll certainly be bigger for certain use cases. But it's definitely a big, important part of the future. So I want to spend a little more time diving into that GraphQL, see if we can get that stuff done with GraphQL, get the data that we need, and then and see if we can pull together the beginnings of an app. Because once we get together, first thing we're gonna do is we're gonna pull in, this data. Then we got to start, then massaging what we want to do once we pull it in. Do we want to decorate things? Want to make things certain colors, or do we want to create charts? Do we want to and then get into alerts and dashboards? So and intelligent functionality. Like if I want to, if I have this list of issue tickets, how then do I actually do something about the issue ticket other than sort or filter, right? We want to make sure we populate it with appropriate links that that allow us to do, CRUD, use this as centralized interface that will not allow us to easily access the type of CRUD that we need to without getting in the way. So that is the top of the hour. Whole lot of thinking about application design. Not as much doing this time, but we're gonna get into. I'm gonna work on this week, and as we build this app out, I have updates. I don't know how long it's gonna take to get us to a running spot. In my head, I would love to say next week I come back and we've got a nice, running, but it can take a lot longer than that. So we'll just keep it going, and that is all I have for the call today. So. Any questions, comments?
Okay, thanks, Art.
Thanks, Meg. Thanks everybody for joining.
Good to see you, Art.
It's good seeing you. How you doing, Nate? How's App Armor World? Oh wait, he dropped already.
Have a good weekend, Art. Take it easy.
Thanks, Peg. Have a good one.
You too.